Hello there, Nareg is here. Today we're going to talk about trigonometric formulas related to sum and difference between angles. So we're going to be interested in cosine of a minus b, cosine a plus b, sine a plus b, sine a minus b. So these are the formulas that we are going to learn. But of course, I will start by doing the demonstration. I will take you through the steps where I will be able to prove and show you how we were able to reach these formulas. At first, we have a trigonometric circle. So we have a trigonometric circle. Now, this circle actually will be having 2 points, the point M, such that the angle between OM and the axis of abscissa is simply A. And another point, N, where the angle between ON and the axis of abscissa will be B. And of course, this circle is, since it is a trigonometric or unit circle, it will be also defined by unit vectors, which are I and J. So this is the unit vector I, and this will be the unit vector J. All right. Once we are going to talk about the arc MN, it's actually the difference between B and A. B is the whole arc from the axis of abscissa till ON, and this is B, minus A. A represents the angle between the axis of abscissa and the vector OM, or the part where I have OM. So MN, it represents B minus A. Now, what about the vector OM? If I'm going to write OM vector, it will be cosine A times I plus sine A times J. This is how it is defined. What about the vector ON? ON is defined as cosine B times I plus sine B times J. Now, cosine, it represents, of course, the abscissa of M. So I will simply show you. It will be this part. All right, this will be the part of cosine A, and this part it represents, of course, sine A. The same thing goes for the other one, where I will have cosine B and sine B. All right. Once I was able to define the vector OM and the vector ON, right now I will do the scalar product. So what about the scalar product OM scalar ON? OM scalar ON, it's cosine A times cosine B. I vector times I vector, it's simply 1. Since I and I are collinear, so it will be 1. So it's cosine A times cosine B plus sine A sine B. Again, J times J is simply 1. So this is OM scalar ON. In another way, OM scalar ON is actually OM in values times OM ON in values times cosine of the angle formed between the vector OM and the vector ON. So it's simply equal to 1 times cosine. The vector between OM and ON is the arc MN, which is B minus A. So these two are simply equal. I can say that these two are exactly the same thing. Now, there is a small thing that I should change. I can also say that cosine of B minus A is actually the same thing as cosine of minus A minus B. So this will be the case of cosine minus alpha, which is cosine of A minus B. So I will have the final formula cosine A minus B will be equal to cosine A times cosine B plus sine A times sine B. So this is how you get your first formula. So whenever you have to calculate cosine A minus B, you simply use this formula. Whatever I did in the previous part is simply the demonstration. I had to go through the steps in order to demonstrate, to prove that cosine A minus B is actually cosine A times cosine B plus sine A times sine B. This is the first one. Now, how am I supposed to calculate, let's say, cosine of A plus B? Very simple. I say that it's the same thing as cosine A minus the angle minus B. So it will look like cosine A minus B. Instead of B, I will have minus B. So I will use the formula. It's cosine A times cosine minus B plus sine A times sine of minus B. So it will give me cosine A times cosine B, because cosine of minus B is simply like cosine minus alpha. It will give you cosine alpha. Sine A times sine minus B. Sine of minus B is very similar to sine of minus alpha. So sine minus alpha, it's minus sine alpha. It's in the fourth quadrant. So I will have minus sine A times sine B. So for cosine A plus B, I can use the second formula. Alright, I will go through sine also. How am I supposed to find sine A minus B, sine A plus B, and then we're gonna take a few examples. So let's go and find sine. So we have sine of A plus B. Let's say I'm interested in sine of A plus B. Now how am I supposed to find sine? It's very simple. You will have to say that cosine of pi over 2 minus A plus B is simply equal to sine of A plus B. We're using the formula, the associated arcs. Cosine pi over 2 minus alpha, it's sine alpha. So cosine pi over 2 minus, instead of alpha a plus b, it will give you sine alpha, which is sine a plus b. Now again, I'm going to use the formula, but here I should make a small arrangement. I can write this down as pi over 2 minus a minus b, which is of course equal to sine of a plus b. I use the formula, so cosine of pi over 2 minus a times cosine of b plus sine of pi over 2 minus a times sine of b is equal to sine a plus b. Cosine pi over 2 minus a is simply sine a. So I will have sine a times cosine b plus sine pi over 2 minus a, it's cosine a times sine b, which is equal to sine of a plus b. And this is how you were able to find sine of a plus b. Again, you simply use the formula. What I'm doing here is a certain demonstration in order to prove how am I supposed to find this formula of sine of a plus b. Now what about sine of a minus b? Sine of a minus b, I will use the previous formula. So sine of a minus b, I will simply say it's sine of a plus minus b. Alright? And it will be just like the previous one where I had sine of a plus b, sine a cosine b, sine a times cosine of minus b, and then plus cosine a times sine of minus b. I will arrange it. Sine a times cosine minus b. Cosine minus b is similar to cosine minus alpha, which is cosine alpha. So you will have sine a times cosine b. Cosine a, sine minus b. Sine minus b is the same thing as sine minus alpha, so it will give you minus sine alpha, in this case minus sine b, so you will have minus cosine a times sine b. So we were able to find that sine of a minus b is actually sine a times cosine b minus cosine a times sine b. Alright? This was the final formula with cosine a plus b, cosine a minus b, sine a plus b, sine a minus b. Now let's take some examples. In which case we're going to use these formulas. So let's say we have to find cosine of pi over 12. Cosine of pi over 12. Pi over 12 is not a particular angle. It's not an angle which I will be able to find easily cosine unless I'm using a calculator. So in this case you simply have to say that pi over 2 is actually pi over 3 minus pi over 4. Alright? So it's pi over 3 minus pi over 4. I will be able to say that cosine of pi over 12 is cosine of pi over 3 minus pi over 4. And I will use my formula. It looks like cosine of a minus b. Cosine of a minus b, what is the formula? I'm going to remind you. So I will write down here. It's cosine A cosine B plus sine A sine B. Alright, this is the formula. So I will use this formula. I will have cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. Alright, so this is for this equal, of course. Alright, cosine of pi over 3, it's 1 over 2 times square root of 2 over 2 plus square root of 3 over 2 times square root of 2 over 2. Your final answer will be square root of 2 plus square root of 6 over 4. So this is the exact value of cosine pi over 12. So I was simply I was able to actually find cosine pi over 12 by using this new formula where I'm doing a difference between A and B. In this case it's A minus B. Another example, let's say I'm about to calculate sine of 5 pi over 12, sine of 5 pi over 12. Alright, so this is the example that I have. I will have to say that 5 pi over 12 is actually pi over 4 plus pi over 6. So sine of 5 pi over 12 is equal to sine of pi over 4 minus pi over plus pi over 6. So you will be using the formula of sine of A plus B. I'm going to remind you about the formula in case you forgot about it. I can go back. So sine of A plus B is here. Alright, so we have sine of A plus B is sine A times cosine B plus cosine A times sine B. Alright, this will be the formula. So I'm going to use it in order to calculate. So it will be sine of pi over 4 times cosine of pi over 6 plus cosine of pi over 4 times sine pi over 6. So it will be square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1 over 2. Alright, so you will get in this case also square root of 6 plus square root of 2 over 4, and this will be the exact value of sine of 5 pi over 12. Alright, I'm gonna give you the final formula. So in order to have the formulas, all of them in one page, I will give them to you. Cosine of A minus B is actually cosine A times cosine B plus sine A times sine B. Cosine of A plus b is equal to cosine A times cosine B minus sine A times sine B. Okay, now what about sine of A minus B? It will be sine A times cosine B minus cosine A times sinus B. What about sine of A plus B? It's sine A times cosine B plus cosine A times sine B. Alright, so these are the formulas related to cosine and sine. Now I will go through the part which is related to tangent. I'm going to discuss and show you how are we supposed to find again this addition or difference of angles. The formula is related to angle sum and difference, but related to tangent. So what about tangent? Let's say I'm willing to find tangent of A minus B. Alright, I'm willing to find tangent of A minus B. I will use the formula. It's sine of A minus B over cosine of A minus B. So it's simply sine A minus B, sine A cosine B minus cosine A times sine B over cosine A times cosine B plus sine A times sine B. Alright, now I'm gonna divide by cosine A times cosine B, so I will have to divide by, so it's a division by cosine A times cosine B. What I will obtain is actually this. So it's equal to sine A cosine B over cosine A times cosine B minus cosine A times sine B over cosine A times cosine B. One more time, cosine A times cosine B divided by cosine A times cosine B plus sine A times sine B over cosine A times sine B, cosine B, excuse me, cosine B. So I will have to simplify first. Cosine B, cosine B, cosine A. In this place, you will obtain 1. So I can simply say that tangent of A minus B is actually equal to, here it's sine A, is equal to tangent A minus tangent B over 1 plus tangent A times tangent B. So this is the formula that you're gonna use related to tangent A minus B. What about tangent A plus B? What about tangent A plus B? So in case I'm interested in tangent A plus B, I will simply say that I can write it down as tangent of A minus B. Alright, so it will be tangent A, just like we had previously done, minus tangent B, but in this case it will be minus tangent of the angle minus B and not B, over 1 plus tangent A times tangent of the angle minus B once again. So what we will obtain is actually tangent of A plus B is equal to tangent A plus tangent B over 1 minus tangent A times tangent B. You simply have to remind yourself that tangent of minus alpha, it's minus tangent alpha. So this is the formula that you're going to use related to tangent A plus B. Now I'm going to take an example. What about tangent of 15 degrees? 15 degrees, it's not a particular angle, but I know that it's equal to tangent of 60 degrees minus 45 degrees. I will use the formula. It's equal to tangent 60 degrees plus minus tangent of 45 degrees over 1 minus, and this is plus tangent of 60 degrees times tangent of 45 degrees. Alright, so it will be equal to tangent of 60 is square root of 3 minus 1 over 1 plus tangent of 60 is again square root of 3. Alright, now this answer, in case you want to rearrange it, you can multiply by 1 minus square root of 3 over 1 minus square root of 3. You will obtain square root of 3 minus 3 minus 1 plus square root of 3 over 1 minus 3. So your final answer will be minus 4 plus 2 square root of 3 over minus 2, so it will be minus plus 2 minus square root of 3. This is the final answer. So this is the exact value of tangent 15 degrees. Alright, now this was the final part with tangent A plus B, tangent A minus B. Now I'm gonna use some particular angles where we are duplicating, where we have, instead of A plus B, we will discuss about A plus A, so I will have to discuss about cosine 2A. So what about cosine of 2A, the double angle? It's the same thing as cosine of A plus A, so it's cosine A times cosine A minus sine A times sine A. So your answer will be cosine of 2A is actually equal to cosine squared of A minus sine squared A. And of course this is not equal to 0. It's cosine squared A minus sine squared A. It's not cosine squared A plus sine squared A. So this is another formula that you can simply use. What about sine of 2A? So sine. I'm gonna talk also about some rearrangement for this formula, we can say that it's equal to 2 cosine squared A minus 1, or it's equal to 1 minus 2 sine squared A. Alright, you can use these formulas also. So simply you will have to remind yourself that I was able to replace sine squared A by 1 minus cosine squared A, or I replaced cosine squared A by 1 minus sine squared A. That's all I did. What about sine of 2A? Sine of 2A is the same thing as sine of A plus A. Again, you apply your formula, so it's sine A times cosine A plus sine A times cosine A. Instead of B, you're using A. So the formula will be sine of 2A is actually equal to 2 sine A times cosine A. Alright, what about tangent? So in case you are interested in also to calculate tangent of 2A, you simply have to say it's tangent of A plus tangent A over 1 minus tangent A times tangent A. So your final answer will be 2 tangent A over 1 minus tangent squared A. So you can also use this second formula with tangent to A. Alright, I'm going to take a couple of examples. So in which case we're going to use the cosine of 2A, so the double angle. Let's say we are interested in calculating again cosine of pi over 12. I can say that cosine of 2A will be equal to cosine of pi over 6. It's the double angle. So cosine of A, it represents cosine of pi over 12. So I will simply have to find a certain relation between cosine 2A and cosine A. So I will get back. I have this formula, 2 cosine squared A minus 1 is cosine of 2A. So I can use that formula directly. So two cosine squared of pi over 12 minus 1 is equal to cosine of pi over 6. So 2 cosine squared of pi over 12 is actually equal to cosine of pi over 6 is square root of 3 over 2 plus 2 over 2. So I'm changing the place of minus 1, it will be plus 1, it will be 2 over 2. So I will obtain cosine squared of pi over 12 is equal to square root of 3 plus 2 over 4. Now I'm interested in cosine pi over 12, so I will have to do the square root of 3 plus 2 over 2, and you choose the positive value and not the negative, simply because cosine of pi over 12 is actually a positive value. So this is the exact value of cosine pi over 12. And of course, in case you want to check this answer with whatever we were able to find previously here, cosine of pi over 12, square root of 2 plus square root of 6 over 4, you will see that it's the same result. Alright, so this was cosine of pi over 12. Well, what about another example? Let's say I'm willing to calculate tangent of pi over 8. Again, I can consider that tangent of 2a is tangent of pi over 4. It's an angle that I know. It's the double of pi over 8. So tangent A will simply represent tangent of pi over 8. And you will use your formula. So I know that tangent of 2a is actually equal to 2 tangent A over 1 minus tangent squared of A. So tangent of pi over 4 is equal to 2 times tangent of pi over 8 over 1 minus tangent pi over A to the power of 2. Alright? Now, in this case, tangent pi over 4 is 1. So you will have 1 is equal to 2 tangent pi over 8 over 1 minus tangent squared of pi over 8. If I suppose that tangent pi over 8 is simply t, I will have this quadratic equation, 1 minus t squared minus 2t is equal to 0. So this quadratic equation, whenever you use delta or simply use your calculator, will give you, of course, two values of t. One of them is negative. You simply reject that value. You consider the second value, which is positive, so tangent of pi over 8 will be equal to minus 1 plus square root of 2. So this will be your answer regarding tangent of pi over 8. Alright, so just like you saw here, that we can use the double angle in cases like this also by simply using the formula that we were able to find. Now I'm gonna take the same formulas and simply go through the half arc or the half angle. So let's say we had cosine of 2a, which was equal to cosine squared a minus sine squared a. From this formula I can deduce that instead of 2a, if it was cosine a, so your formula will be cosine squared of a over 2 minus sine squared of a over 2. Okay, so this formula again you can simply use it in case you didn't have 2a, you were using in your exercise simply cosine of a and you need to find a over 2. So this formula will also help you. We can do the same thing with sine. So sine of 2a, we know that it's 2 times sine a cosine a. From this formula we can deduce again that sine of a is actually equal to 2 times sine of a over 2 times cosine of a over 2. One more time, this formula it could be used directly. And what about tangent of tangent of a? So tangent of a will be equal to 2 times tangent of a over 2 over 1 minus tangent squared of a over 2. Alright, so I'm gonna simply write it down again. So it will be equal to of tangent squared of a over 2. This formula, again, you can use it directly. Now, the last part, how am I supposed to find a certain formula between sine and tangent, or cosine and tangent? So this will be the last part. So these previous formulas that we were able to find, this one and this one, I'm going to use them again. I will start by sine. So we had sine of a is equal to 2 times sine of a over 2 times cosine of a over 2. I will divide by 1, and instead of writing 1, I can simply say it's sine squared a over 2 plus cosine squared a over 2. And I'm going to divide the whole fraction, the numerator and denominator, by cosine squared a over 2. So I will divide by cosine squared a over 2. What I will obtain is actually this is equal to 2 sine a over 2 times cosine a over 2 divided by cosine squared a over 2. The fraction, so I will simply write down again, is equal to sine squared a over 2 plus cosine squared a over 2, one more time, divided by cosine squared a over 2, and in this case also cosine squared a over 2. I will have to simplify cosine a over 2 and cosine squared, so here I will be able to find 2 tangent a over 2 over 1 plus tangent squared a over 2. So this is the formula for sine A. This is a formula that you can use it directly between the angle, let's say A and the half angle a over 2 by using sine and tangent only. One more time, the last one will be with cosine. So we had cosine A is equal to cosine squared a over 2 minus sine squared a over 2. Again, I will divide by 1, and 1 is actually cosine squared a over 2 plus sine squared a over 2. One more time, I will divide the numerator by cosine squared a over 2, the denominator also by cosine squared a over 2. So what I will obtain is this, so it will be equal to cosine squared a over 2 minus sine squared a over 2 divided by cosine squared a over 2 divided by cosine squared a over 2 shall equal to cosine squared a over 2 plus sine squared a over 2. One more time, cosine squared a over 2 and cosine squared a over 2. So, in the first part, cosine squared a over 2 and cosine squared a over 2, I will have 1 minus tangent squared a over 2 over 1 plus tangent squared of a over 2, and this will be cosine of a, and this is the last formula in this part. Yes, these are the formulas related to the sum and difference between angles, and of course you can use them directly without these demonstrations. In this video I was going through each step in order to demonstrate how I was able to find the final result or the formula that we are using it directly. So these steps are simply to demonstrate, these steps are simply the proof in order to reach the final formula. I hope it was helpful, and I hope, why not subscribe to my channel. You will be notified whenever I upload new videos, and I can also share with you my Instagram, Facebook account. You can contact me directly, or you can simply leave a comment below. I hope you it was helpful, and I hope to see you next time.